Welcome to the course of Applied Mathematics 3, starting with the topic of Laplace transform. Now, Laplace transform, the name transform itself says that we are transforming from something to something. What is that? Actually, Laplace transform is a tool basically used to solve differential equations in engineering. What we do with the help of Laplace transform, we transform a function f of t. Here, f of t, what does it mean? It means the function is dependent on t for its values. That is, it is dependent on time. We do not time by t. The function is depending on its values for the function is dependent on time for its values. We convert this function into frequency dependent function. Here where frequency is denoted by s. We convert its dependency from time to frequency. That is, we convert a function in time domain to frequency domain. Initially, before transforming the function, it is a function of time. After transforming or after taking Laplace transform, it is function of frequency denoted by s, where s is the complex frequency, that is s is equal to sigma plus j omega. We will not go into detail of this. We will just consider s over here, where sigma is the real part of the frequency and omega is the imaginary part. We will just focus our concentration on s. In general, we will say that it is a function of s. That is, in short, Laplace transform converts a function from time domain into frequency domain. Now we will see the basic definition. If f of t is a function, then its Laplace transform is denoted by L of f of t. That is, L of f of t equal to 0 to infinity f of t e raised to minus st dt. This is the basic mathematical formula of Laplace transform. Now we'll see some problems related to it so that you will get a hold of it. If it is given, consider the first sum. F of t is equal to 2t for t 0 to 2 is equal to 0 for t greater than 2 to infinity. Now, what is the general formula of Laplace transform? They have asked to find Laplace transform, that is to find L of f of t. Now, what is the general formula? L of f of t is equal to 0 to infinity e raised to minus st f of t dt. Now just substituting the values of, before substituting the values of f of t, we will just split its domain. That is 0 to t function is different. 0 to 2 function is different, and then from 2 to infinity function is different. After this, we will just substitute the value of f of t, that is 0 to 2 e raised to minus st dot, what is that f of t? It is 2t plus 2 to infinity e raised to minus st plus 0 dt. So this term whole will cancel out to 0. So now I will just remove this 2, take it outside. 2 0 to 2 e raised to minus st t dt. Now this is my L of f of t. But now here there are two types of functions, that is, one is algebraic and one is exponential. So by default we have to apply the which rule? We have to apply the partial integration by parts rule. What is that integration by parts? Integration by parts, we use this integration of parts formula when there are two different types of functions and under the integral, that is u v dx, where u is different and v is different. Basically there are 5 different types of functions according to Lie rule: logarithmic, inverse, algebraic, trigonometric and exponential. Here in this 5 there are exponential and algebraic, this and this. According to Lie rule, coming from left to right, algebraic comes first and exponential is second. Here we denote the first function by u and second function by v. So by integration by parts rule, the formula of u v dx is u integration of v dx plus plus integration of d by dx of u integration of v dx. This is the formula. So we'll apply it. We'll just apply it over here, or we'll just rub the initial things. And I'll rewrite over here. L of f of t is equal to 0 to 2 e raised to minus st t dt. Taking this as v and this as u. 2 u integration of v, t integration of e raised to minus st dt minus d by dt of t dot, what is v, e raised to minus st dt. Applying this formula over here. So now I'm just rubbing this part and I will be applying, after that I will be applying over here the limits to, what is this, t e raised to minus st by minus s minus, what is this, differentiation of t is 1 e raised to minus st dt so 2 t e raised to minus st by minus s minus e raised to minus st by minus s dt is equal to 2 t e raised to minus st by minus s plus this minus minus get cancelled, e raised to minus st by minus s square. Now just taking this minus and 2 minus sign, I will take it outside, so it will be t e raised to minus st, and I will also take e raised to minus st. I will not take e raised to minus st outside, as it contains t e raised to minus st by s plus e raised to minus st by s square by 2. Now just L of f of t is equal to minus 2 e raised to minus s into 2 by s plus e raised to minus 2s by s square minus 0 e raised to 0 by s plus e raised to 0 by s square minus 2 e raised to minus 2s by s plus e raised to minus 2s by s square minus e raised to 0, that is 1 by s square. Now just taking minus 2 inside, it's minus 4 e raised to minus 2s by s minus 2 e raised to minus 2s by s square plus 4 upon s square. This is my L of f of t. Writing in general, actually here there is a partition, don't get confused. So this is my actual, if I make it as phi of s is equal to 4 upon s square minus 4 e raised to minus 2s by s minus 2 e raised to minus 2s by s square. This is our s domain equation, that is L of f of t. In this way we are going to solve each and every problem, basic problem of Laplace transform.